Welcome everyone. Critical members of the audience have arrived, parked their car, and it's brilliant to be here tonight to welcome you to the inaugural lecture of Professor James Norman. My name is Tansy Jessup. I'm the Pro-Vice Chancellor for Education here, and I'm delighted to be doing the second of my inaugural introductions in a row in this very lecture theatre. It just tells me what leaders in the field you engineers are. But onward and upward, I wanted to say what a real privilege and honour it is to welcome you tonight to Professor James Norman's inaugural lecture. James exemplifies what it means to be a professor who carries the torch for education and brilliant teaching. In James, we see a kind of delicious alchemy of academy, industry, sustainability, love of students, well-being, and outstanding teaching. He is an outstanding teacher, recognized by a string of personal achievements. A National Teaching Fellow, the highest accolade for teaching in the UK, rated highly again and again in Bristol Teaching Award lecture nominations, voted by students in the prestigious Best of Bristol Lecture Series, and consistently scoring 4.5 out of 5 for unit evaluations. He is described by students as engaging, fun, and giving the best classes ever. But it's not only the students who love him. The Joint Board of Moderations, accreditors, who visited in 2018, told Simon Neild that it was the best prepared case he had seen in 18 years of doing his role accrediting civil engineering courses. So what makes James outstanding? I'm going to say there are 5 or 6 things, but I bet there are more. I think the first thing that makes James outstanding is he makes the subject come alive in real settings. All of us who know James will know that he exemplifies the best of the industry-academy partnership. Now, it's not intuitive that you get this here. Any of you who've read David Lodge's novels and the one called Nice Work will know getting academy-industry partnerships to work is a tricky business, and James does it well. He does it by simulations, by real partnership with industry, and by his fantastic authentic learning and assessment. We all know The Office, and it's not the one with Ricky Gervais. It's James's office, his project design team meetings, which students say help them get jobs. There's an alumnus who said, this helped me get my jobs. So it builds in students skills for employability. I gather that alumni across the world are using project design notes crafted by James. His teaching is creative, fun, accessible, and he makes complicated ideas simple, which is the heart of good teaching. A second reason why James is outstanding is he's a bit quirky, imaginative, and he takes risks. Those of us that know James will know he does things like 50 slides in 5 minutes, where you start and you think, you can do 50 slides in 5 minutes and make that powerful and interesting. And you sit down and you are just wowed. That's one of the first presentations I saw James give, and I said, you have to apply for National Teaching Fellowship. But colleagues attest to his quirkiness in other ways. Sarah Allsorts helps here tonight. And she wrote to me about James and said, what also stands James apart is his willingness to share, to offer advice and practice ideas, but also his own personal experience and journey, which makes it all the more valuable and appreciated. He also, this is the quirky bit, he also introduced me to drinking coffee in an Edwardian toilet. Former, of course, the Cloakroom Cafe on the corner of Park Road and Woodland Road, that apparently does a fantastic white. So I don't know how many of you been to the toilet with James, but it sounds more exciting. The third reason why I think James's teaching is outstanding is he makes everyone feel like they matter. And Iden talks about, in speaking about James, when they were discussing the Cain Common first year, James said, what we want to do here is to take everyone, regardless of where they come from and what background they have, and give them a real chance of doing well in our programs from year 2 afterwards. And Iden said, this statement for me defines what James is about. Being fair to all and giving everyone a great chance to learn. Another example of his everyone matters is a bit more prosaic. Apparently that very accreditation visit which James did so brilliantly took place in heavy snow on a cold January day. And the university closed for lunch with students in the room. And James was very concerned about the students' capacity to get home in their vans and their trainers. So he hauled out a whole lot of sight boots so students could wear their sight boots home because they mattered. You will find that James's research reinscribes the value of mattering. He's doing work on decolonizing architecture, moving from looking at big imperial designs to thinking, how do we decolonize architecture? So there's an inclusive strand to James's work which is really impressive. A fifth reason why I'm losing count, James's work is impressive, is he takes action to improve things. We see it in what he talks about tonight, sustainability. He's future-focused, he's thinking about the younger generation, the survival of the planet, and he's taken me to task on Temple Quarters architecture and whether it is really compliant with all the sustainability. I shouldn't say this in a corporate setting, but there's a sense in which James is doggedly determined that we do sustainability right. And I think that is a beautiful thing. For me, I got to know James a bit when we had the COVID pandemic and had to go online quickly, and he was incredibly helpful in setting up some of the digital design coursework on authentic learning. There's a fantastic story that probably you don't know, but a lot of the uptick in the NSS in civil engineering comes from quite intentional improvement work that James led. He ensured that the score moved up from 80 or 85% in civil engineering, and it's sitting in the 90% at the moment, through ensuring staff went to training about teaching, visiting Sheffield who were doing better than us, and revising the units. On the subject league tables, civil engineering has moved on the Guardian league table from 17th to 14th, and on the Complete University Guide from 5th to 3rd. This is good news. Well done, James. I think another reason why James is outstanding, and which is one of the linchpins of being promoted on an education pathway, it's ironic, but writing really matters and scholarship really matters. And James is passionate about writing, about teaching, and his discipline. It helps him and us to think more deeply about what we're up to. If you look at his CV, you'll see that James is busily beavered away on 3 books, 8 journal papers, and if you go onto the Built website, there are 24 blogs, and he's done about 15 refereed conference papers at last count. He's the author of a, would you believe, a best-selling book on conceptual design. And it is, the reviews say, this is the, I mean, it's not going to rival some of the crime fiction, but you know, this is the fastest selling book in the Institute for Structural Engineering series that has been published in the last 10 years and possibly ever. And even stronger, this is the new Bible for students to understand conceptual design from Joanne Thomas at the University of South Wales. This is exciting. And James's work plays out with people. His writing is not privatized. His scholarship is not just about him, it's about us. So he was core to setting up the Engineering Education Research Group, don't confuse it with the ERG, and he's created a community who think about the scholarship of teaching and learning in engineering and beyond. James is brilliant. This is about the sixth thing. There must be seven. About in helping others to know and value their talents. Simon, the head of school, said, he is always very supportive of colleagues and has helped many Pathway 3, which means they're on an education pathway, staff develop their CVs with an eye on their careers and their promotion. A quotation from one of them, thank you so much for your support when I was applying. All the information and your feedback were incredibly helpful. Simon said, nice to see it coming full circle and him getting his chair. And then we have Marie Annick in the audience, and I just want to read her beautiful tribute to you in closing. I was looking for someone to mentor me for my associate professor application, as there are very few Pathway 3 professors, and the one in my faculty was already involved in the promotion process. HR advised me to contact a couple of colleagues, and James was one of them. His support and guidance were invaluable in me getting my promotion. He was extremely generous with his time, guiding me through the form and inviting me to reflect and value my achievements. He would invite me to walk through what I considered insignificant and part of my way of working, and point out the importance of what I was doing and the impact of my work. I was immensely appreciative for his commitment to supporting me through this process, while he hardly knew me. After submitting my application, James continued to check in with me at every stage of the progression of the application. He was the first person I contacted when I received my promotion. I am infinitely grateful for his support. He is very caring, generous, and down to earth. And he is a person that I am pleased now to have as a friend. I give you Professor James.
Thank you so much for that. That was really, really kind and actually quite awkward to listen to. It's not really my thing. So this evening, what I'd like to do, and I'll be honest, I've tried this with my third years at 1 o'clock today, and we did get through the entire content in 51 minutes, but I might take a little bit longer, so apologies in advance. But what I like to do is talk to you about sustainable design, which is something that I'm incredibly passionate about, and talk about kind of the past, where we're at now, and most importantly, what needs to happen next. And so I wanted to start by telling you a little something about where I live. So welcome to my street. This is actually where I live. I took this photo not that long ago, and you can kind of have a little look around. It's kind of a 1950s to 80s council estate. There's lots of different types of housing here, including some very kind of rapidly built houses that were built straight after the Second World War, which are prefabs, and were supposed to be around for 20 years. As I said, this video was taken very, very recently, so they've clearly been around for a lot longer. Now, what I would like to do at the very beginning of this presentation is for us all to jump into our time machines and to jump forward to 2050 and to look at what the world might look like in 2050. And so we're back at the same scene, we're looking at the same street, all the same houses are still present, but there's also quite a lot of changes that you might be able to see, and I've got the pictures as individual pictures so we can dwell on them a little bit longer, but you can see lots of different things going on. We've converted space that was just kind of parkland and turned it into places where we can make food for each other. This is my favourite detail. I'll get to that in a minute, but we'll just look at some of these for a little bit longer. So this is a house, and we've changed the way it works. We've overclad it, so make it much better in terms of insulation. We've got lots of solar panels and all sorts of other solar devices on the roof. What you can't see, but for me as a structural engineer, the most important thing is we've now got a whole load of water storage tanks up in the roof. In fact, they're mostly people's baths because it's quite expensive now to have a bath in 2050, and they want to store their water, so they just move their bath up into the loft. And as a structural engineer, my job is to make sure that this still all stands up. So I need to design and check the roof, and actually I'm going to recommend to my neighbours that they swap the joists around between the first floor and the roof, because most floors are over-designed but most roofs are under-designed. So actually the engineer is going to be very busy in 2050. There's going to be a lot going on. There are other things going on in this space. So we've got the lack of cars, we've got most importantly, this is what I'm most excited about. This thing with a blue door is actually a communal composting toilet, which we'll all be sharing. And we'll all be sharing because it will produce excellent fertiliser for our shared growing. But this particular communal composting toilet is actually built from the remains of a building which collapsed, one of those 1920s houses, which no longer was structurally viable, and it did actually sadly collapse. You can see the ruins in the background. And as an engineer, my job is to forage for all the useful parts and to turn it into something else. Nothing is going to be wasted, hopefully, in 2050. We don't just chuck stuff away. We reuse everything, so I made a composting bin and a toilet out of it. So as a structural engineer, I'm going to be really busy doing lots of different things. This is just one of many scenes. This is just the scene on my street. There are all sorts of other scenes that we could visit as well if we had time. So that's where I think we could end up. Now what I'd like to do is jump back in time, in our time machine, to where this all started, for me at least. The year now is going to be 1977, the year of my birth, and apparently some film called Star Wars, which some of you may have come across, came out at the same time. I think I've what's the word, matured much better than the film. I actually don't. I think Star Wars is excellent. So this is me, 1977. Yeah, it's a flattering photo, I think you can agree. And so why jump back to 1977? Well, for me, it's obviously important because it relates to when I was born, but actually there's other stuff going on. So we're going to be coming back to this graph over and over again and see what happens, but you'll also be able to see at the bottom of the slide, we're going to have the year and also that graph kind of in miniature just in the corner. And so in 1977, we're already starting to see a rise in the amount of atmospheric CO2 which leads to climate change. And not only do we see a rise, but actually we already know that there's a problem. This is something people are talking about. This is, as luck would have it, The Guardian produced a whole load of articles from their archive about 4 days ago, and this is one of them. This is an article from 1978 which talks about climate change. It talks about the impact of climate change, the possible changes that we might see. We've known about climate change for a very long time. People have been talking about it for a very long time. People have been choosing to not do enough about it for a very long time, as we will see. Now, I thought, whilst I was in the formative years of my life, I might tell you a little bit about who I am. And many things have changed for me over the years, not least my hair. So here we go, 4, we're up to 12. This is me, age 17, and my hair for a short while was very long. I then, in 1998, so this is actually at university, this isn't one of my children, this is the baby of a friend of mine at the time, but I bleached my hair blonde, and then this is where my hair went into steady state, which is non-existent, from 2006 onwards. So as you can see, some things have changed for me during the years, but actually a lot of things have stayed the same through the years. So I think I was always an engineer. This is me at a science festival, actually down just by College Green in the kind of big Bristol City Hall, presenting a science project. And I was doing all sorts of things like this. The other thing, and I'm going to come back to this, but my very lovely PhD students made me a present for tonight. Congratulate me. And it's, I don't know if you can see all of this, it's a giant Lego brick. I am renowned for my love of Lego, and you know, Lego is like the the soul food of engineers, kind of this amazing stuff. So I've always been an engineer. I remember buying, for like my 13th birthday, technical drawing pens. What kind of a 13-year-old buys technical drawing pens? But apparently I did, because I always wanted to be an engineer. I also have, I think, always been, in one way or another, a teacher. So all of my family are here, which is amazing. And I grew up amongst teachers. So my dad was a head teacher, my mum is a teacher, my sister was a teacher and became a head teacher, my wife was a teacher and has actually just gone back to doing some teaching. So I've spent my whole life kind of in amongst teachers, and I never wanted to be a school teacher, but I think I always wanted to teach. So that is one of my constants. And the last one is, I was brought up in a Christian family. I've always been a Christian, and actually I try and bring my values into everything I do, and Tansy really kindly mentioned some of the things I do, and I think that comes a lot from that values for me personally. The other thing I thought I'd mention is my socio-political positioning, which also hasn't really changed. And this is important because we're talking about the climate emergency. I think I'm noticing where I fit on the scale. But it is important because actually the climate emergency has a very political edge to it, and often people aren't honest about who they are and where they come from and what their political ideals are and what they're trying to achieve. And I think everyone should say where they sit on, this is called the political compass. I think everyone should declare it when they start talking about this stuff so that you know where they're coming from. I think it's helpful, it's honest. And I just happened, as chance would have it, and I didn't do the questionnaire 473 times to get this outcome. As chance would have it, I genuinely didn't, I only did it once. And I happened to just land slap bang between Gandhi and Nelson Mandela, which, who can argue with that? It's delightful to be able to share that. When I was just 11, I moved to Bath. And I soon went on to a school called Ralph Allen School, which will come back up in our presentation. And I was there for the whole of my education, secondary education. Around the same time, 1990, the IPCC was created. And really importantly, we went past 350 parts per million in terms of the carbon dioxide concentration in the atmosphere. And this number, 350 parts per million, has been the focus of kind of where people think or were thinking we need to get back to. And this year, 1990, is kind of fairly important. In 1994, I did my GCSEs, and Tansy mentioned all my writing, which if you told my 1994 self that I'd spend most of my time writing, I would not have believed you. I used to go to additional lessons at school for writing and reading. It wasn't really my strong point. I was much better at maths and science. So in fact, for GCSE, I didn't, do fun. Well, okay. My best marks were A's in maths and science. My worst mark was D in French, which I just could not get for the life of me. And English was probably the mark I was proudest of because I worked my socks off to get a B. Writing was really not my strong suite. I just was very happy doing maths. I then went on to my A-levels and did what I would consider the boffin's choice, and I've heard it used, but I called it that this afternoon to my students. I had no idea what I was talking about, which was shocking to me. I mean, surely everyone knows what the boffin's choice is. Do you know what the boffin's choice is? So, wait, what? Come on, louder.
Maths, physics, chemistry.
Yeah, and further maths, if you want the full house. So I did the boffin's choice. Unfortunately, at the time, my school didn't actually teach further maths, so they gave me textbooks, and I did that in my additional time. But I did the classic boffin's choice. And I went on to the University of Nottingham, where I wanted to become a civil engineer. And at this point, I really wanted to become a civil engineer because I really wanted to have a positive impact on the world, and that hasn't changed. And I thought I was going to be a water engineer. I was told if you want to have the biggest impact in terms of people's lives, give them clean water and sanitation, and that's what I wanted to do. So I went to the University of Nottingham to study water engineering and learn about how to do that. And I thought it was going to be amazing, and it was. So I became a civil engineer, and at Nottingham University, I met my future wife, which was amazing, and we are still together, and she was a special person we all celebrated walking in. So, around that same time, now in, but I...
Wondering if your future wife is different to the way.
She was my future wife in the... I seem to recall us getting married in 2001. 1997, we started talking more and more about greenhouse gases. We weren't putting anything into law at this point, but we were aware there was a problem, and people were talking about doing something about it. 1999, this is my research project, and the very last time I thought about water engineering until I gave a lecture last year on it, on a unit that I delivered. So this is designing stormwater sewage outfall and working out what's going on with it. That was my undergraduate research project, and after that I never did water engineering again because I became a structural engineer. So a structural engineer is someone who designed buildings, and so I joined a company called Whitby Bird at the time, and I worked on a number of really interesting projects. So my first ever project was this, the University of Gloucestershire, Oxtal's campus, and this project was actually fairly remarkable because back in 2000 they were thinking about the climate emergency, they were thinking about energy usage, they were thinking about how to minimise energy usage in this building. We were using the building itself to cool the air, to minimise energy usage, and it won a number of awards, which was exciting to be involved in. And this building is made out of steel. This is a glass table that I designed at the Tate Modern in St Ives, and my now wife, then at the time I was designing it, not quite wife, really this was the moment that she discovered that she had someone who was going to take her on holidays all around the country looking at buildings that he designed, because on our honeymoon we happened to accidentally visit this particular building with my glass table in, and I went missing for about an hour as I took lots of photos of it. So I am slightly obsessed with in fact I've stopped it now because it's not so well received, but I do love taking people around in my family and showing them buildings that I have designed. The next project I worked on was Telford International Centre, which is another steel frame project. And then in 2002 I met one of my loves. It's not my first love, but one of my many loves. I designed my first ever concrete frame building, and anyone who knows me well will know that ever since I've been a significant fan of concrete. It's phenomenal stuff. It really is amazing. And so this is Darwin Court up in London, and this was the first concrete frame building I designed. In 2003, I then worked on another project where I was designing timber, so I was now designing out steel, concrete, timber and glass, so that was excellent. And then in 2003, the opportunity came up for me to apply to do a PhD at the University of Bristol. So I applied, and I actually got a job, so I joined Bristol as an RA, a research assistant, even though I didn't have a PhD. I persuaded them that my 3 years of experience of designing buildings was equivalent to a PhD, and so Adam and crew very kindly offered me a job, and I came and worked for the university where I was modelling earthquakes in the lab. So we designed and built this rig, which basically takes very big structures, long bridges, and it looks at how the ground moves differently along the length of it, and we modelled that and captured what happened and how it behaved, and that was very exciting. And so I did that for 3 years, but the real reason I did a PhD was because I really wanted to get into the university so I could teach. That was kind of my real driver. That was my game plan. My kind of long-term goal was to be a teacher. And I understood that to be a teacher, you had to have a PhD. It's not actually so true anymore, but certainly at the time, that was definitely the case. And so in 2003-04, I gave my first ever lecture. It was with an overhead projector. Anyone remember overhead projectors? Come on. I really love overhead projectors and all the slides. It was really satisfying. It was on structural dynamics, and I'm pretty sure I spoke for the entire 2-hour session without taking a breath, with pause, and my poor students left exhausted. Although they weren't that negative. And I think if I was to do it now, I think it's much harder. The expectation for the quality is much higher. I don't think I would have got away with it these days, but at the time it went okay. And in fact, it went so well that the next year, Adam allowed me to teach his steel design course, and I started teaching steel design alongside doing my research, which was excellent. Really enjoyed doing that. And so a couple of years later, I passed my PhD, which was, it was easy, just a trifle. I just breezed through it. I really didn't. It was awful. It was a horrendous time in my life. But anyway, we got there. We got it done. We also, my middle son was born in the middle of me writing up, which, as anyone who knows what writing up is like will know, is not the best timing. And I was working part-time in engineering by this point, and 2 days a week I was teaching. So I was actually kind of mixing, writing my PhD until about 2 o'clock in the morning, doing the bottle feeds and trying to hold down a job and working. So I was pretty grumpy for just a teeny tiny little while. But this was quite a big period in my life where I went into this space where I was working as an engineer 2 or 3 days a week or 4 days a week for a big chunk of it, and I was teaching on the other days, and I kind of enabled the two things to talk to each other and overlap and connect with each other. I also went back to Whitby Bird, back to designing buildings. They got bought out by a company called Ramboll, so I started working for a company called Ramboll, who are a very large, 10,000 strong Danish designing company. And I worked on some little projects like this one. This is the Ferrari Experience. I was just designing the roof because the roof alone is £300 million and is 1 kilometre across, so it's quite big. So this is out in Abu Dhabi. I moved on to this, which is not only my least favourite project, but I've been told by quite a few people is that the worst thing they've ever seen, or more importantly, driven up. It's a car park ramp that you drive up at St David's 2 in Cardiff. I would recommend avoiding it because it's apparently very not nice at all to drive up. And then I moved on to this project where I was overall designing the building. This was my kind of first really big project where I was running the entire thing. So this is a office building on something called Green Park. And I learned a really valuable lesson on this project because this project was on something called Green Park, so it was suggested it was super sustainable. And the client really liked the idea of sustainability. They liked it so much that they wanted to put solar panels on the side wall of this building to show people how sustainable it was. Anyone who knows anything about solar panels will know that you don't put them on the side wall, you put them on the roof and you point them towards the sun. So we had some conversations, would you like to put them on the wall and on the roof maybe, so you can actually collect some energy as well as making it look like you're collecting energy, or would you like to just put them on the roof and not waste your money on the ones on the side wall? And they were very clear, they only wanted to spend money on the ones that people could see, even though they don't do anything. And actually, this was a big learning point for me because as a still fairly young structural engineer, I objected and I kind of, said this is ridiculous. But at the end of the day, they didn't put the solar panels on the roof and they did put some on the side wall. And I didn't do anything to stop them. And I remember presenting this project a few years later and someone asking the question, you work for this massive organisation. They've got, huge amount of agency. You could have absolutely put a stop to this. You could have walked out. You could have done all sorts of things. And it made me realise that I could have done more to challenge the client on this project. And that doesn't mean it's easy to do more, but I could have done more. Whilst working on this project and all these projects, I also took a number of these photos, which will be really meaningless to you and not particularly exciting. But to me, they're very important because what I was really doing is I was teaching a day a week and I was collecting as many examples of what I was teaching about out in industry to show to my students during my sessions on Friday. And so this is the formwork for a concrete column. It looks like a giant toilet roll. And if you're building columns and they're round out of concrete, this is what you use. And actually being able to show that to a student and explain how it works, and I've got thousands of these. Anyone who would like to see them all is more than welcome to indulge themselves in an excellent evening of concrete details and all sorts of things. But actually for students, that is super valuable to see what this stuff really looks like, really matters. And so I was able to not just think about my day job, I was able to think about what would be useful for my students when I'm walking around site, when I'm doing what I'm doing. And so the two things really complemented each other really well. And I think it was really beneficial to do both. And this is probably I don't know if it's the biggest project. It's not the most expensive, but it's the one I've put most of my life into. So this is Oxford Brookes University, and I spent, I stayed here 2008 to 11. I spent 3 years solidly working on this project, and I was overseeing it as the engineer. I spent another 2 years kind of doing bits and pieces on this project, and this project was a fairly big deal. It went on to win all sorts of awards, sustainability awards. It was medium listed for the Sterling Prize. I was very sad it wasn't shortlisted, but it was medium listed. And one of the big things about this project was it was incredibly sustainable. It was using all sorts of quite new technology to minimize the amount of energy that this building was using. So I just wanted to pause and talk about something called operational versus embodied energy and explain the difference, because you may not have thought about it, but when you look at this picture, this building won lots of awards for sustainability, but it is made out of humongous amounts of concrete. What you can see in this picture is huge walls made from concrete. And back in the kind of 2010s, everyone was obsessed with reducing operational carbon, the amount of carbon we produce through operating the building. Now, you might be thinking, what on earth is he talking about? Operational energy carbon is the carbon we produce by operating it. It's the lights we turn on. It's the projectors. It's the heating. It's the air conditioning. It's all the stuff that we're worrying about right now as we read the press about the price of electricity and gas. And we're thinking, should I turn my heating on or not? Should I turn off my lights all the time? Should I, kind of be using this piece of equipment or that piece of equipment? Should I go around and turn off everything that I'm not using in case it's drawing energy without me knowing? All of that stuff is operational carbon. It's the carbon we produce when we run all of those devices. However, there's something else called embodied carbon, and the embodied carbon is the carbon that goes into actually building the thing. Now, around the time of this building, everyone was obsessed with operational carbon. The people who design the mechanical and electrical parts of buildings wanted to be called sustainability engineers. They were like, we're all about sustainability. What we do is reduce the carbon, call us sustainability engineers. No one was really talking about embodied carbon. And so this project, which won all of these sustainability awards, had a humongous embodied carbon footprint. And you might think, so what? Why does that matter? Well, according to Bill Gates' book, and I'll be up for debating how accurate it is, but according to his book, making stuff accounts for 31% of emissions. That's a big amount. Most people think that the way to save the planet and to reduce carbon is to not fly an aircraft. That when you talk to people, aeroplanes is the thing they tend to talk about. If we all stopped flying, we'd save about 2.5% of the carbon emissions. So there's still another 97.5, and 31% of that is in the stuff we build. Now, it's complicated because making stuff accounts for not just buildings, it accounts for all sorts of stuff, but concrete alone is about 8% of global carbon emissions. And except for really wacky coffee machines that are made out of concrete, nothing is really built from concrete except for buildings and infrastructure, bridges, dams, drains, that sort of thing. So that 8%, that is down to us as engineers. Steel is another 8%. Some of that goes into other industries, cars, aeroplanes, that sort of stuff, but some of that also goes into our buildings as well. So we are producing a huge amount of the world's carbon emissions. It is a big deal. Engineers, structural engineers have a huge part to play. So I thought that was a useful pause. We'll keep coming back to that idea, but I thought I'd tell you about this project, which is probably my most favorite project I ever worked on. I only did a tiny bit on this. I did the initial conceptual design of this building. It's a timber box building, so it's made out of wood. And this project is at Ralph Allen School, which is where I went to school. And not only is it where I went to school, it's also where 2 of my now 3 children go to school, because one of them has just left because he's now too old to go to school anymore. So he's got a job instead. So this building is special to me for that reason, but it's also special because I actually think it's a beautiful building. I loved working on it. I loved collaborating with the architect. And I actually think it's a fantastic just piece of engineering. I also carried on working at Ramble, and I also designed some other buildings like this. This is the extension to the Tate Modern, which was one of the hardest years of my life working on this project. But I persuaded my wife that I really should do it because it will be on my CV forever, and it is, and I love telling people about it. I once sat on a train from Bristol to Bath, in which I generally try not to talk to anyone on the train, but randomly talked to the person, and we spent 9 minutes me hearing about his job and what he did. And then just before I got off, he asked me what I did, and I told him what I did. And I told him I designed this, and he spent the rest of that minute just swearing at me because he couldn't believe I designed the table. He was like overwhelmed by it. So I worked on that as well. Whilst at Ramble, I also started to get involved again in research. So I supervised an engineering doctorate by Ellen Grist, and she was looking at lime concrete along with loads of other stuff. And I was also still teaching. And this map, believe it or not, I drew in 2007 when I was trying to persuade the University of Bristol to give me a job as a lecturer. I was unsuccessful at that time. But I was thinking about the course and how it all connects together and all the interconnectivity. And I was particularly interested in teaching about something called sustainable structural design back in 2007. That unit finally happened in 2011. So I actually made that unit and created it and turned it into something that I started teaching. And I delivered that unit for a number of years. And what I realized as I was teaching that unit is that I was teaching about really unusual building materials like round earth and straw bale, but I wasn't actually doing it. So I've been designing buildings out of steel and concrete, and then I've been teaching people how to do it. I was suddenly finding myself not designing buildings out of the materials I was teaching about and trying to teach about it, and it just didn't add up to me. So I left Ramboll and I joined this company, Integral Engineering Design, and I started doing some more interesting projects. I've thrown this picture in because, first of all, I wanted to remind myself to tell you that everything you've seen is a team effort. Engineering is not an individual pursuit. You never, ever design a project on your own. In fact, I never, ever designed a project from beginning to end, with one exception. I always took projects on from someone else, or I passed them on to someone else. And you're always working with a whole load of professionals. And actually, engineers generally don't shout about what they do. They try and hide it away. In my experience, we're not great at telling people about what we do, but we are excellent at working in teams. It's essential to what we do, and actually it's what we do all the time. The other reason I wanted to include this photo is because it really makes me smile, or drawing, because actually this drawing is based on a real photo of my company that I work for, Inaugural Engineering Design, who were the most diverse company I'd ever worked for. Half the staff are female. Now, the numbers changed, but now 2/3 of their directors are female. And yet, when I produced this drawing and I gave it to the Institute of Structural Engineers for a book that I was writing, they told me I couldn't use it because it was all men. And so that just made me laugh, because actually it was a drawing of my company, which was much more diverse than anywhere I'd ever worked, and probably most engineering companies in the country. Whilst I was working there, I designed buildings out of round earth. This is a small wedding venue made from round earth. This is the one project I designed literally from beginning to end, where we designed a school, and it had to be done in a year. It had to be open in time for all the children to come. So we did it all together. It was a massive collaboration. And actually, my favorite thing about this project is the very first meeting, we all came together. It was a very tight deadline. Everyone had to work really hard. We had to work together. There was, kind of quite a lot of testosterone and sort of, commercial kind of wrangling going on, and all these people in suits, except probably me, because I never wear a suit. And the head teacher walks in, and she stands up in front of this very, very sort of big meeting with lots of important professional people, and she read them a children's story. And it just transformed the mood. And suddenly everyone went from being quite combative to completely sharing the same purpose, which was to build a school for children so that they could learn. And it was this amazing transformative moment. And I've stolen that and I've used it in my teaching. And I often read children's stories to my students. And I did think about doing it tonight, but I decided not to because of time and also because of technology and trying to make everything work. But it was a lovely moment. This is a random project, but it's a little project that I worked on where we were the lead engineers, and it's a research facility for the University of Bath. This is another timber project, Springfield campus. So I was working on all sorts of interesting things. And actually, I realized I did work on a straw bale project, and I forgot to include it. So we were working on all sorts of interesting things. Now, in the background, whilst all of this is going on, our CO2 emissions on this planet are still going up. And in fact, rather than getting back to that 1990 level of 350 parts per million, in 2013, we passed the threshold of 400 parts per million. We are, not only is it not going down, it's not even slowing down. The rate at which we're producing carbon dioxide is actually increasing. Now, in 2015, I became a full-time lecturer. So I was lecturing a bit, I was working in the industry a bit, and finally in 2015, I persuaded the University of Bristol they did want to employ me full-time after all, and I became a full-time lecturer. And at this point, and I've got 3 reflections in this talk, and this is my first one. I think it's worth just saying that I realized as I was writing this talk that I've had 4 or 5 changes of career over the time I've been working. And when I went from industry to do a PhD, I took quite a big pay cut. When I went from doing my PhD, I did try and get a job at the University of Bristol, but they wouldn't give me one. So I got a pay rise when I went out into industry, but that wasn't my first choice. That was like my plan B. Once I was in industry, back again. I took another pay cut to leave Ramboll to go and work at Inaugural, but I did it because I wanted to learn about how to design out of different building materials. And then when I left Inaugural and became a full-time academic, I took another pay cut. And that's not to say that I'm hard off, because I really am not. I mean, I'm a professor. If you're a University of Bristol employee, you can look up what I earn on our system. But every time I changed jobs, I did it because I wanted to learn more. I wanted to do what was right. I wanted to kind of develop myself in new ways, try and have more impact. And so I've always tried to do what's right, not what pays. So this is me, 2015. This is one of my concrete lectures. The queues were round the block. We had about 6,000 people come. That's not actually true. It's a joke. This is actually me giving my Best of Bristol lecture, where 400 people did come, and it was a huge amount of fun. And I really enjoyed myself. But this is not what my concrete lectures looked like, although there was a lot of whooping and cheering during concrete lectures, because, it's concrete, and why wouldn't there be? And when I was writing my Best of Bristol lecture, I was thinking a lot about sustainability, of course, because it's what I ever think about, and concrete, because that's what I also think about a lot. And I was thinking about the interface between creativity, which is something I'm very passionate about, knowledge, which is something that I deliver as a lecturer, and risk. How do we know if what we're doing is safe? And actually, that's a conversation I've been having for a long time, and we're going to circle back to that, because these things keep coming around. 2015 was also when the Paris Agreement was signed, and people, at least in theory, legally signed up to reducing their carbon emissions. And in the summer of 2015, I'd just become a full-time academic, and someone called Simon Smith, who used to be a director at Ramboll, he set up his own practice called Smith Will Work, and he contacted me out of the blue, and he said, I've just heard you've become an academic, and it's the summer, and you'll have literally nothing to do, because academics just sit around twiddling their thumbs in summer, right? And I really want a book on how to do the initial design of timber buildings. Would you write it? So I said, yeah, sure. And so I was approached and asked to write this book. And so that summer, that's what I did. I just sat and I spent the summer writing this book, which was fun and a great experience. It was the first thing I published of significant, kind of input, which was lovely. And then a couple of years later, so I'm still an academic, I'm still teaching, I'm still doing bits and pieces. I applied for a built fellowship, Bristol Institute of Learning and Teaching, because I wanted to learn more about pedagogy and how you actually teach. Because what I've discovered is I do loads of stuff because it seems like it's the right thing to do. What I haven't been so good at is actually understanding why it's the right thing to do and how we can talk about it and how we can share about it. And that was a pretty big deal for me because actually I did things like I started blogging, and as you'll recall, I wasn't very confident at writing for a long time. And that previous book is I think, very useful, but it's just factual. There's no real soul to it. It's just here's a load of information that you can look up. And so when I started blogging, I started to find a voice and a way of communicating, and that was very exciting. And I was doing research into the space in which we teach. And Tansy mentioned as well something called authentic learning. So learning in a way which kind of connects with the world beyond academia. And so I invented this thing called The Office. And I was going to take a short kind of 4-minute, I've cut down my slides so it's only 4 minutes now, and tell you a bit about The Office. So as you know, I design buildings. And actually, this is where I work. This is Integral Engineering Design's office. I took the photo after I left. So when I designed my timber unit, I wanted to design it in a way which replicated that space. I wanted to help students learn about timber or wood. It's a non-technical word. And I was thinking about the space that they were going to learn in. And I asked myself some pretty big questions. So where do we learn? Where do we learn? If we're going to learn to drive a car, what space do we learn in? Well, we learn to drive in a car. If we're going to learn to swim, I don't know if anyone else has had swimming lessons not in a swimming pool. Most of us probably have them in a swimming pool. Even when we teach people how to be dentists, we create spaces for them to learn to be a dentist. So when you're learning to be an engineer, we, in fact, put you in this very room. And that's not actually fair, because learning about engineering is done in lots of different ways. We put people into labs and they make concrete, because why wouldn't you? I mean, what a joyful way to spend some time. We take them out on site and we show them what building sites actually look like. We take them into design spaces where they work as teams and they do design work using old-fashioned drawing boards. We take them out into the field where they survey the world around them out in Pembrokeshire. In fact, the one place we don't seem to replicate as a learning environment is actually this place that most consultants, at least, will spend their time, The Office. So I created a space where they could come and learn. And actually, I did it by creating my own pretend company, which was called Just Timber. And it had its own logo and brand. And it had its very own joke. I'm hoping the joke's going to appear, otherwise it's going to be awkward. Yes. It had some calculation pad. I created my own marks. I created the actual office space. I spent literally an hour every week moving everything around to set it up to look like an office with its own breakout space. I took those chairs down from my personal office. It had its own entrance with a sign by the door, so you knew you were walking in to Just Timber Engineers. And of course, it had a tea point. And obviously on my birthday, which just happened to fall on the day I was teaching it, my wife very kindly made everyone cakes, which I brought in. So my employees, they're no longer students, they're employees. They came and worked for a day a week for 10 weeks, 9 to 5. And at the end of the working day, I made them pack all of their stuff up and put it in boxes and try and walk away. There were no lectures. This is pre-pandemic, so that was a fairly big deal. Instead, there was pre-reading and lots of videos. And I'm hoping when this comes up, I might have to click that and hopefully you can see. So there were videos that then they would work their way through and watch. And so they could turn up to the office ready to be engineers to actually do the work. So employees worked on 4 authentic projects in the authentic learning space. They had real briefs, actual projects with real briefs that they might see in an industrial context. Real bad drawings, which were hard to interpret and had missing information that they had to find the gaps on. Real context, projects that actually were real, and they had photos showing them what was going on. And even real clients. So Dave from Bristol Old Vic came and spoke to the students and pretended to be the client for a project that they were working on. And the first 2 projects were designed to teach them what they needed to know. And then the last project was there to assess them. And it was a whole load of fun running the project. You can read all about it. Tansy mentioned it on my 12-part serial, The Office, which I greatly enjoyed. So that was a little pause and a little advert for The Office. back to the main presentation. What happened next? So what happened next is 2020. And in 2020, I accidentally published 3 books in 1 year, which I would not recommend to anyone. The first book I published in 2020 was this one, the Conceptual Design of Buildings book, which Tansy mentioned. And it included this chapter on questions we must ask. And I wrote at the beginning of this chapter, I have a confession to make. I hope that it is 5 years from now and that you are holding this book in your hand, wondering why it's so obsolete, why the solutions you want to explore are not covered, and why only outmoded and old techniques are included. And I wrote that because I really do think the industry needs to change and the way we do things needs to change radically. Now, I've told you about this chapter not because it's brilliant, but because it was never going to be in the book. I wrote the book and I gave it to the reviewers, and this chapter wasn't there. And one of the reviewers, Tim Idle from Bath University, he said, the thing your book is missing is this chapter, which was hilarious because it's the thing I'm really passionate about and spending my time talking about, but I was too scared to put it into the actual book. And so what was really nice is Tim challenged me and said, you have to write it. And it took about a day to write. If that, I just, it was inside of me. I just literally had to put it onto paper. It literally took no time at all. And it's the thing, so this guy, Terry, from Australia, he emailed me or messaged me on LinkedIn, actually, a couple of weeks ago and said that he thought it was a great thought piece. So that would never have happened if Tim hadn't approached me and said, you actually need to do this thing. And coming back to that picture of team, most of the things, the first book I wrote, I wouldn't have ever written if Simon hadn't made me write it. This book wouldn't have had that chapter if Tim hadn't made me write it. So actually, I'm always looking to kind of work with other people and work in a team. I also wrote this book in 2020, or published this book, Designing Timber Structures. This is actually another misstep. This book shouldn't really exist. I was going to write a book called Designing Concrete Structures. And I went to Wiley, who are a well-known publisher, and we got all the way up to the point of them costing the project and seeing how much it would be to produce the book. They were up for it. And they found out, and I still question their numbers significantly, but apparently the readership was not high enough for a book on concrete, and they didn't think they were going to make a profit, which I think is outrageous. I think they've completely misread the market, but that's what they told me. And I got that email as I was waiting to meet someone from Trada, who were the publisher of my first book, to talk about some things to do with my first book, and I was waiting for them, and this email came in as I was drinking my coffee before we met up, and I was a bit gutted, and then they turned up, and I was like, do you want to publish a book called Designing Timber Structures? And I literally removed the word concrete and put in the word timber, and off we go. Suddenly I find that I'm writing books about designing timber structures, which is really, really exciting, and actually, again, it's probably much more what I'm passionate about. But again, I thought the market was going to be there for something else, but it turns out it wasn't. And then the third book I accidentally wrote in 2020 was nothing to do with engineering at all, but it's to do with creativity. And I wrote a book about how to run your own micro record label. And I don't know if you noticed there was music playing when you walked in, but that was music from my micro record label. In my spare time, I do run a micro record label, and I shared with people how to do that for themselves. So 2020 was a big year in terms of accident, and it was accidentally, because they were all supposed to come out in different years, but just as things happened, they all came out in the same year. So 2020 was a big deal. Oh, and I don't know if anyone else remembers 2020, but something else happened in 2020. So I survived the pandemic. My office project did not survive the pandemic. It was sadly not able to run during the pandemic. And the next 2 years, my lecture theatre, this room here, suddenly looked a lot more like this. This is my temporary makeshift lecture theatre where I was working for a good chunk of the time. Also in 2020, I became much more active in talking to industry about net zero and designing buildings which were more carbon efficient. And I started writing blog posts and writing articles and doing other things. And this is a diagram that we produced a few times, which is based on something that someone else published, which is just talking about different ways to reduce the amount of carbon in our buildings to try and make them better for the environment. And we, again, were thinking about, or I was thinking about how we bring in the idea of being creative and knowledge and risk and how this all interrelates. And it's still an ongoing conversation for me, and we were starting to challenge people about. So this is an article in the Structural Engineer, which is actually a really good read. Genuinely, I really love it. And we started talking about, can we start reusing existing buildings and starting to challenge people on that? And still, with all of this work, still our CO2 levels continue to rise, and the trajectory isn't slowing down in any way, shape, or form. So, what now? What's next? Well, in 2021, I read this book called Donut Economics. Has anyone read Donut Economics? Come on. I really enjoyed it. There was about 3 pages which I found genuinely transformational in my thinking, which were really worth it, because it made me realize that actually all the time we've been talking about reducing carbon and looking at this diagram, every single one of the projects that we were talking about was still producing carbon and actually was therefore doing harm. And it made me realize that as engineers, our goal was to do no harm. Our goal was to kind of get to that point where we do no harm. And yet all we were doing was missing our goal. So we were setting this goal of do no harm, and then we were missing over and over again. And in 2021, I discovered that actually there's a kind of a space where you go beyond do no harm. It's called different things. In that book, it was talked about being generous. We move beyond just doing no harm, and we move into this new space. And it's really challenged me in my thinking and how I approach things. I also discovered by going to the Institute of Structural Engineers Awards ceremony, which I went to and was lots of fun. And I sat on the table with authors for the Institute of Structural Engineers. And I was asking them about what books they wanted to write. And they were all telling me about the books they wanted to write. And they all sounded like books that I'd already written. And I tried to not take any offense at the fact that they were basically saying, the book that you wrote, I'd like to write a much better version of it. But then I realized, and it was a really useful aha moment for me, that they were very capable of writing much better versions of the books that I'd already written. But it was going to take them a very, very long time. And I've discovered that what I can do is write books that hopefully people find useful, and I can do it very, very quickly. So I've decided to embrace the fact that I'm a punk rock author. And so what that means is that in 2022, me and my friend Ollie, who is here, we decided that we'd write and publish a book in a year. And that book would be about this idea of going beyond do no harm and going into the space of being generous and something called regenerative design for structural engineers. And what I also discovered is structural engineers don't know what this is. They have no idea what it looks like. There is no map. There's no kind of, this is the answer. If you just do X, Y, Z, you'll get there. And so the book that we wanted to write is going to be quite challenging. In fact, it's going to be really challenging to write because we don't know what it looks like. We're kind of working it out as we go along. It's a bit like if I was to write a book about riding a bike. Now, you may not know this about me. I'm 44 years old and I still cannot ride a bike. This is me and Ollie. He's trying to teach me how to ride a bike. I didn't actually fall off the bike. I posed myself as if I'd fallen off the bike and taken a photo. But if I was to write a book about riding a bike, I wouldn't write it knowing how to ride a bike. I'd write it about what I was learning as I tried to learn to ride a bike. Now, if you want to read a book about riding a bike, don't read my book, because there are lots of other people out there in the world who can ride bikes and can do it really well. And you should probably read their books. But if you want to read a book about regenerative design, what we discovered is no one else has written a book for structural engineers about regenerative design. That manual doesn't exist. No one knows what it looks like. And so we thought, we're going to try and put a book out there that challenges people. So we're going to learn to ride that bike and share it. And one of the things we're going to do is actually not just share the outcome, the product, we're going to share the entire process. We're going to show you every time we fall off. Try and share some of the disagreements, try and be honest about what's going on. We're going to tell you that we wanted to write the book in a year, and it's probably going to be 18 months because, things take longer than you originally thought. And so every step of the way, we wanted to share our process about the writing this book. So That's one of the books that is currently going on. The other book that's currently going on is this book called How to Design Absolutely Anything. And this book is all about how to design absolutely anything as a structural engineer. And it's related back to my work as an academic, as a researcher. So as well as teaching, I still am research active. You can see two of my projects here. So on the left, we've got Joshua Mooney's Timber Concrete Composites, and Joshua is sat, I think I saw you at the back. There you are, right in the middle. Good job. And on the right, we've got Dominica's work that's currently going on in bamboo. And I also, look at this, this is incredible. I'll show you my diagram. But this was a gift from Dominica and Luca. And it's made out of two things. It's made out of bamboo, which is Dominica's research, and it's made out of cross-laminated timber, which is Luca's research. And so we're trying to learn how to use materials that other people don't know how to design with. We're trying to learn how to design anything, but more than that, we want to teach practicing engineers how to design absolutely anything, because the reality is we now need to change, and we need to change very, very quickly, and we no longer have time to wait for all of the kind of processes that normally happen in building design to happen. So, for example, we are being told that we need to halve emissions by 2050. That's quite a big deal. Now, you might think, well, that's still 7 years away. It's not 7 years away. If you're designing a project like Oxford Brookes University, that took 8 years from conception to delivery. So you should have started the design with 50% less CO2 last year. If you design the Tate took 15 years from conception to delivery. So that should have been half the CO2 levels in 2015. We don't have 7 years to make this change. We've actually already used up on these big projects a lot of the time we've already got. In fact, we're going to really struggle to get to 50% by 2030. That is the reality. So we need to be thinking differently. We need to be thinking about using different materials, being creative, approaching things in very different ways. And we need to start radically rethinking how we use our existing buildings. And reusing buildings needs to become the default for the projects that we do. Not kind of a nice to have, but it really needs to be what we do as automatic. We need to be way quicker to adapt. What I've basically explained to you over the course of my lifetime is that structural engineering has changed very, very little, really. A concrete beam is still a concrete beam. And if you go and look at concrete projects, and you wouldn't believe it, but when I walk through Bristol, I stop and take photos of building projects all the time, because I still do. But they're all the same as the ones that I was designing 20, 30 years ago. We haven't adapted, and we need to be a lot quicker. So projects that we start now will be complete in 2030, so we need to change now. And so the thing is that my second reflection, I have three, and this is number two. I used to think that the climate emergency was a challenge for future generations. I became a lecturer because I wanted to teach future generations how to design buildings differently. But what I've come to realize is that our time is up. And actually, we need everyone who is still alive to be changing things. And we need practicing engineers particularly to act now, that there is no more time to wait. There's no point teaching someone how to design buildings sustainably at university if they go into a practice which is going to stop them from doing everything they've learned. We need to change everything we're doing, and we need to do it now. This isn't a future problem, this is a now problem. And people like me and a lot of you in the room actually need to be doing things differently now. What next? So 2030 to 2050, we keep going. We need to keep cutting CO2. We need to get to net zero emissions and beyond. And it's the beyond that I'm excited about. What does it look like to do things so differently that we can't even imagine it right now? And that's where we get into the regenerative space that we've been thinking about and playing with and pretending to fall off lights whilst talking about. And 2050 is going to be different. Me and Ollie talk about this quite a lot. 2050 is going to look different to now. If we choose to do nothing now, 2050 is still going to look different to how things look now. We either choose to act or we choose not to act, but 2050 will be different. There is no two ways about it. So my third reflection is we've spent the last 30, 40 years doing, I'm 44 years doing nothing. And the less we act now, the more we need to act later. And people start talking to me about my ideas that they're quite radical and why do we need to change so quickly? The reality is, if you imagine you're driving a car, probably a bad analogy because they use petrol, but let's go with it. We've been past and we're on a motorway and we're coming up to a junction and we've been past the 3 and we've been past the 2 and we've been past the 1 and then there's the dotted line and we've chosen to ignore that. And we're now thinking, shall I turn off now and go over all the bumpy lines and all of that stuff? That's where we've got to. And if we'd chosen to start indicating and turned off as we should have done on the junction, it wouldn't have felt rapid and crazy. But we've chosen not to act, and so therefore now we need to act very, very rapidly, and it feels quite scary. So we need to just be thinking completely differently as structural engineers and as everything else. Whatever field you're in, we will need to think creatively. We'll need to think differently. We need to think beyond do no harm. So how can we actually restore environments and the damage we've done? How can we go beyond that to regenerative? And if you gave me another 6 hours, we could unpack that and tell you exactly what that was all about. I've put those 2 words down at the bottom because they're really important. And again, we could spend hours talking about it. But I think we need to be thinking globally in terms of we need to be learning from each other globally. There are so many interesting projects and ways of doing things that we don't see in our UK context. I actually am mentoring an engineer who works in Uganda. And we were talking about the projects he was working on, and he reminded me that in Uganda, 90% of their energy is renewables. But it's nowhere near that in the UK. I was talking to an engineer out in Rwanda who was designing rammed earth buildings, and in Rwanda, they've realized how important it is to reduce the carbon impact of their building projects. So they've codified how to design rammed earth buildings. We haven't got that in the UK. We're not doing that. So we need to be learning from across the globe. But actually, the solutions and the way we think, I think, needs to be more local, not in my backyard, NIMBYism, let's make this as small as possible, but in a how do we actually minimize the impact of everything we're doing, and how do we explore and understand the impact, and how do we use our local knowledge to improve our designs, which is why we ended up at my front door at the very beginning, because I think engineers more and more will be working not in a global way, but in a local way. They'll be thinking about how they can solve local problems. They can use local materials as much as possible, not completely, but as much as possible. They'll be reusing local buildings. They'll be deconstructing local buildings to make new buildings. They'll be doing things using what is available to them. And so that is where I think we're going to get to, I hope. I asked the Structural Engineer, which is a magazine about engineering, to make me this cover, and I just really like it, so I thought I'd share it. It's got some ideas about what 2050 might look like. We might be talking about some new things like designing using mushrooms, building buildings out of mushroom. I'm pretty excited about that right now. I think it's the future. We'll see whatever happens. There's going to be some ongoing conversations around things like inclusivity in the workplace, and some conversations, and if you're not an engineer, I'm afraid this one will be not particularly funny, but if you know about this and you've been reading The Structural Engineer, the fact that David Bron is still going to be writing in every month about quantitative analysis and education, I think is almost certainly going to happen in 2050. And so things are going to change, and there'll be new problems and new challenges, but also things will stay the same. So that's where we're going to hopefully get to as engineers. We're going to be designing in our local environment. This is again Bath, where we're now reusing existing buildings. We're overcladding buildings. We're finally building wind turbines here, there, and everywhere to generate as much energy locally as possible. We're using all of the local resources. And I think structural engineers will be busier than ever. And I think that they will be, with the automation of calculations, they'll actually be doing harder and harder. They'll have to be more creative. They'll have to be more mathematically aware. They'll have to overcome significant challenges in a really positive way. And I think it's really exciting if we can get past kind of where we're at right now, which has been stuck and not being able to change things. So if we can get beyond that into 2050, I think it's very exciting. And that's it.
James, I want to thank you for a rousing, stirring, urgent, fascinating tour of your career. I think for me, the headlines are about how we all make a positive impact. And we're all immensely impressed with your boundless energy, endless strength. And we've seen the powerful combination James brings of telling stories, his imagination, the visualization of 2050 and back and the time machine, and evidence on every single slide of the climate emissions. Each slide has shown that, and James has managed to take us on a journey from 1977 that's been amusing, that's shown us his baby pics, the disappearance of his hair, and the constants in James' life. I was always an engineer, I was always a teacher, I was always a Christian, and I'm a punk rock author. An odd combination. And I think we saw in the 4-quadrant slide, James's values captured in the little dot between Nelson Mandela and Mahatma Gandhi. And we were delighted with some of the one-liners around your now and future life. But really what we saw is how when you enable your values to line up with your work, you make magic. And James, you make magic. And we thank you for that.